February 7, 1918, 1523 hours, Springfield Armory, Massachusetts. Captain William Hayes, 31 years old, U.S. Army Ordnance Department, stands at an indoor firing range, holding a weapon that represents either brilliant innovation or engineering absurdity. He genuinely cannot determine which until testing begins. The base weapon is immediately recognizable, a Colt M1911 pistol, the .45 ACP semi-automatic that has served as the U.S. military's standard sidearm since 1911. 7 years of service have proven the design robust, reliable, and effective at its intended role, providing officers and specialists with a powerful defensive weapon for close-quarters engagements at ranges under 25 yards. But the pistol Hayes holds has been transformed by a modification that seems to violate every principle of pistol design. Protruding from the magazine well is a massive cylindrical drum magazine, measuring approximately 6 inches in diameter and 2 inches thick. The drum, fabricated from sheet steel with a spring-wound mechanism inside, holds 40 rounds of .45 ACP ammunition arranged in a double-stack spiral configuration that feeds into the pistol's action. The mathematics seem impossible. The drum weighs 3.8 pounds when loaded with 40 cartridges, more than twice the weight of the empty pistol itself, 2.44 pounds. It extends so far below the grip that one-handed shooting becomes awkward, and the weapon's center of gravity shifts dramatically forward and downward. The M1911 was designed around a 7-round single-stack magazine that added minimal weight and bulk. This drum increases ammunition capacity by 470% while destroying every handling characteristic that makes pistols practical. Hayes's superior officer, a colonel from the Ordnance Department's Small Arms Division, had explained the development yesterday with the kind of desperate optimism that characterized much American weapons experimentation in early 1918. The war in Europe has demonstrated that 7 rounds provides insufficient capacity for sustained combat. Officers leading assaults need firepower approaching submachine guns without the bulk of long weapons. This drum magazine transforms the M1911 into a sustained fire weapon while maintaining pistol portability. If successful, it could eliminate the need for dedicated submachine guns entirely. In 18 minutes, Hayes will fire the first shots from the drum-fed M1911, attempting to determine whether the weapon can function reliably with a magazine never designed for the pistol's mechanism, whether the added weight makes the weapon controllable, and whether 40 rounds of .45 ACP delivered from a pistol provides any tactical advantage worth the compromises. He has no idea if the M1911's magazine catch can retain the drum's weight under recoil. No idea if the feed mechanism can reliably strip cartridges from a spiral drum while the pistol cycles at 4 to 5 rounds per second. No idea if this represents the future of infantry sidearms or just another failed attempt to make one weapon do too many things. But in 18 minutes, he'll discover whether extended magazine capacity can transform pistols into primary combat weapons, or if some firearms roles are simply too fundamentally different to be combined, regardless of how much ammunition you can fit in a magazine. World War I had created numerous tactical challenges that stressed the limitations of conventional infantry weapons, and by early 1918, U.S. military planners were acutely aware that U.S. forces entering European combat would face situations where standard equipment proved inadequate. The M1911 pistol, adopted in 1911 after extensive testing and evaluation, was designed to meet specific requirements, replace the underpowered .38 caliber revolvers that had shown insufficient stopping power during the Philippine-American War, provide officers and specialists with a defensive weapon that didn't interfere with their primary duties, and deliver reliable function in adverse conditions while remaining compact enough to daily carry. The design, created by John Moses Browning and refined by Colt's Manufacturing, achieved these goals admirably. The .45 ACP, automatic Colt pistol cartridge, fired a 230-grain bullet at approximately 830 feet per second, generating 350 foot-pounds of energy, sufficient to incapacitate human targets reliably at defensive ranges. The semi-automatic action allowed faster follow-up shots than revolvers. The 7-round magazine capacity seemed adequate for a weapon intended primarily for emergency defensive use. By 1917, however, combat reports from European allies suggested that pistol rolls were evolving in ways the 1911 design brief hadn't anticipated. Trench warfare created numerous situations where officers and soldiers needed sustained close-range firepower. Trench raids. Small teams would infiltrate enemy trenches during darkness, engaging defenders at ranges of 5 to 20 meters. These encounters were sudden, violent, and often involved multiple opponents in rapid succession. 7 rounds could be expended in seconds, and reloading under stress while engaged with enemies proved difficult and dangerous. Tunnel warfare. Both sides excavated extensive tunnel systems for mining operations, creating confined subterranean battlefields where rifles were too long and unwieldy. Pistols and clubs became primary weapons in these environments, but magazine capacity limited sustained engagement capability. Stormtrooper tactics. German development of infiltration tactics, Stoßtrupp doctrine, emphasized small, heavily armed assault teams penetrating defensive lines. Allied forces recognized the need for similar capabilities, requiring weapons that could deliver sustained fire during rapid advances through enemy positions. Officers leading assaults. Junior officers led platoon and company attacks across no man's land, requiring weapons they could use while coordinating troops and maintaining situational awareness. Rifles demanded two-handed operation. Pistols allowed one-handed firing while the officer retained use of their other hand for signaling, map reading, or movement. French and British experience demonstrated that officers armed only with pistols often found themselves inadequately armed when assaults devolved into close-quarters fighting in captured trenches. The standard 7-round capacity provided approximately 8 to 10 seconds of firing before reload, insufficient for engagements that might involve dozens of enemies in confined spaces. The French had addressed this partially through adoption of the Ruby pistol, a 9mm semi-automatic with a 9-round magazine. The British issued revolvers holding 6 rounds, though some officers privately purchased semi-automatic pistols with higher capacity. Neither solution provided the sustained firepower that combat reports suggested was needed. The emerging Thompson submachine gun, under development by Army Ordnance Corporation since 1916, represented one approach, a dedicated automatic weapon firing pistol ammunition at high cyclic rates. The Thompson would eventually use 20 or 30-round stick magazines or 50-round drums, providing sustained firepower from a shoulder-fired weapon. But in early 1918, the Thompson wasn't yet in production. The first prototypes were still undergoing testing, and production wouldn't begin until 1919, too late for WW1 use. American forces deploying to France needed solutions immediately, using existing weapons and manufacturing capacity. Springfield Armory's Small Arms Division began exploring extended magazine options for the M1911 in November 1917. The initial concept was straightforward. If magazine capacity is the limitation, increase magazine capacity through larger magazines. The first approach attempted was the simplest: extended stick magazines holding 15 to 20 rounds in a single stack column, similar to the standard 7-round magazine, but longer. Engineers fabricated several prototypes in December 1917, creating magazines that extended 4 to 6 inches below the grip. Testing revealed immediate problems. The extended magazines were awkward to carry. They couldn't be pocketed and protruded far enough to interfere with prone shooting positions. More critically, the single-stack design created spring tension issues. A spring strong enough to reliably feed the 15th or 20th round was so stiff that loading the magazine required substantial force, and the compressed spring created drag that sometimes prevented the slide from stripping cartridges cleanly during rapid firing. The second approach examined double-stack magazines, similar to designs used in some European pistols. A double-stack magazine could hold 12 to 15 rounds in the same length as the standard 7-round magazine by stacking cartridges in 2 columns that tapered to a single feed position at the top. This required redesigning the magazine well and grip, effectively creating a new pistol rather than modifying existing M1911s. With hundreds of thousands of M1911s already manufactured or in production, redesigning the weapon wasn't practical. Any solution needed to work with existing pistols to avoid disrupting production and logistics. The third approach, and the one that led to the drum magazine experiment, was inspired by the Luger P-08's snail drum magazine, the trommel magazine that German forces had deployed in 1917. If a drum magazine could reliably feed a pistol with 40 rounds, why not adapt the concept to the M1911? The engineering challenges were substantial, but the concept offered potential advantages over stick magazines. Compact form factor, a drum magazine's circular configuration allowed high capacity without excessive length. The mass was distributed in a disc rather than extended vertically, potentially offering better balance than stick magazines. Proven concept. The Luger drums had demonstrated that spiral-feed drum magazines could work with semi-automatic pistols, reducing technical risk compared to entirely new designs. Existing manufacturing. The machinery and expertise for producing drum magazines existed from the Luger production, potentially allowing rapid development and production using known manufacturing processes. Upgrade path. Drum magazines could be issued to existing M1911 pistols without weapon modification, allowing fielded weapons to benefit immediately rather than requiring replacement or retrofit. Development of the M1911 drum magazine began in January 1918 at Springfield Armory, led by a team of engineers including civilians from watch and clock-making industries, specialists in spring mechanisms and precision metalwork. The project received priority designation and a compressed development timeline. Produce functional prototypes by February for testing and evaluation. The design that emerged borrowed heavily from the Luger drum, but adapted for the .45 ACP cartridge and M1911 interface. Drum body, a circular housing measuring 6.2 inches in diameter and 2.1 inches thick, fabricated from 20-gauge stamped steel, approximately 0.035 inches thick. This construction allowed disassembly for maintenance and repair. Spiral track. Inside the drum, cartridges were arranged in a double-stack spiral, making approximately 2.5 complete rotations from the outer edge to the center feed point. The spiral track was formed by stamped ridges in the drum body that created channels guiding each cartridge. The .45 ACP cartridge measured 1.273 inches overall length and 0.476 inches diameter at the case head, requiring precise spacing to prevent binding or misalignment. Spring system. A clock-type mainspring wound around the central hub provided rotational force to advance cartridges through the spiral. The spring was fabricated from tempered music wire, carefully heat-treated to provide consistent tension throughout its range of motion. The spring made approximately 8 complete rotations when fully wound with 40 rounds loaded, storing significant potential energy. Magazine interface. The drum's feed tower terminated in a set of feed lips identical to the standard M1911 magazine, allowing the drum to insert into the pistol's magazine well and interface with the slide and feed ramp exactly as a standard magazine would. The magazine catch engaged a notch in the drum's base plate, retaining the drum in the pistol during firing. Loading mechanism. The drum incorporated a folding key that engaged the spring hub, allowing the operator to wind the spring while loading cartridges. The loading process required inserting the key and rotating it several turns to preload the spring, inserting cartridges one at a time into the spiral track starting at the outer edge, and releasing the key slowly to allow spring tension to engage the cartridge stack. The complete drum weighed 11.2 ounces empty and 3.8 pounds loaded with 40 rounds of .45 ACP ball ammunition. For comparison, a standard 7-round M1911 magazine weighed 2.8 ounces empty, 13.5 ounces loaded. The drum was thus nearly 7 times heavier than the standard magazine when loaded. This weight had dramatic effects on the pistol's handling. Center of gravity shift. The M1911's empty weight of 39 ounces or 2.44 pounds combined with the 3.8-pound drum created a total weight of 6.24 pounds. More critically, the weight distribution shifted the center of gravity approximately 4 inches forward and 2 inches below the normal balance point. The pistol became distinctly muzzle-heavy and front-bottom-heavy, fighting against natural pointing and creating torque that tried to rotate the weapon downward. One-handed shooting difficulties. The standard M1911 was designed for one-handed operation, allowing officers to use their free hand for other tasks. The drum-fed pistol's weight and awkward balance made one-handed shooting fatiguing and difficult to control. Most operators found two-handed grips necessary for any sustained firing. Holster incompatibility. The drum's 6.2-inch diameter made it impossible to use standard M1911 holsters. The weapon couldn't be carried on the hip in any practical manner. This meant drum-fed pistols needed to be carried in hands or slung on straps, acceptable for immediate combat but impractical for soldiers who needed sidearms for extended periods. Prone position interference. The drum protruded approximately 5 inches below the pistol grip, making prone shooting awkward. Shooters needed to dig depressions for the drum or shoot from sharply angled positions that degraded accuracy and comfort. Drawing and manipulation. The drum's bulk made drawing the weapon from any carrying position slow and awkward. Speed reloads, dropping an empty magazine and inserting a fresh one, were slower with drums because the weight and size required more deliberate handling. The first 3 prototype drums were completed on February 5, 1918. Initial bench testing, firing the pistol secured in a vise to test mechanical function without human variables, revealed several problems. Feed reliability issues. Approximately 12 to 15% of feeding cycles showed hesitation or incomplete feeding, where the slide didn't fully strip a cartridge from the magazine or failed to chamber it completely. The spring tension, while adequate for the first 35 rounds, weakened as the drum emptied, and the final 3 to 5 rounds sometimes fed sluggishly. Magazine catch strain. The weight of the loaded drum created substantial downward force on the magazine catch, the small lever that retained magazines in the pistol. After approximately 150 rounds of firing, the magazine catch on one test pistol showed visible deformation from the stress. The catch was designed to retain a 13.5-ounce magazine, not a 3.8-pound drum. Drum robustness concerns. The stamped steel construction, while adequate for static loading, showed stress at the seam where the two halves joined. After 200 rounds of firing with the associated recoil and vibration, one drum developed a slight separation at the seam. This didn't cause immediate failure, but suggested potential durability problems with extended use. Ejection pattern changes. The added weight changed the pistol's recoil dynamics. Empty cases ejected with different velocity and angles compared to standard magazines, occasionally striking the shooter or failing to clear the ejection port cleanly. This created occasional stoppages where empty cases didn't fully eject and interfered with the next round chambering. Engineers made several modifications to address these issues. Reinforced magazine catch. The magazine catch was redesigned with heavier material and a stronger spring, increasing retention force by approximately 40%. This prevented deformation but made magazine insertion stiffer. Operators needed to firmly slam the drum home to ensure the catch engaged. Improved feed lip geometry. The feed lips were polished and the angles slightly adjusted to improve cartridge presentation to the slide. This reduced feeding hesitations from 12 to 15% to approximately 6 to 8%, still higher than the 1 to 2% stoppage rate with standard magazines, but acceptable for experimental equipment. Reinforced seam construction. The drum seam was redesigned with a brazed joint in addition to mechanical crimping, creating a permanent bond that prevented separation. This added manufacturing complexity and cost, but ensured structural integrity. Spring rate adjustment. The mainspring was replaced with a progressive rate design that provided stronger tension as the drum emptied, compensating for the reduced cartridge stack weight that normally helped push rounds to the feed position. This improved feeding of the final rounds from sluggish to reliable. By February 7, 1918, 3 improved drums were ready for live-fire testing with human operators. Captain Hayes received the assignment to conduct the evaluation. Being both an experienced pistol shooter, he had competed in pre-war service pistol competitions, and an engineer capable of documenting technical performance objectively. February 7, 1918, 15:41 hours. Hayes inserts the loaded drum into the M1911, feeling the weight drag the pistol downward. The magazine catch clicks home with a solid snap, the reinforced catch doing its job. He racks the slide, chambering the first of 40 rounds. The familiar mechanical action of the M1911 is reassuring despite the unfamiliar weight distribution. Target downrange, a standard pistol qualification silhouette at 15 yards, well within the M1911's effective range and appropriate for the close quarters combat scenarios the drum magazine was intended to address. Hayes assumes a two-handed grip. One-handed shooting with this weight is possible but uncomfortable. He aligns the sights, controls his breathing, and begins deliberate, aimed shots. The first shot discharges normally. Recoil feels slightly different. The added mass dampens the muzzle flip somewhat, but the weight shift creates a tendency for the pistol to torque downward and to the left for a right-handed shooter. He compensates, realigns, fires again. By the 5th shot, a rhythm establishes. The drum-fed pistol functions mechanically. The action cycles, cartridges feed, empty cases eject, but the handling is undeniably awkward compared to the standard M1911. The weight creates fatigue in the wrists and forearms. The balance fights against natural pointing. Hayes fires 20 rounds in approximately 45 seconds, a deliberate pace allowing careful aim between shots. The target shows reasonable accuracy, All 20 rounds impact within the silhouette's center mass area, a group approximately 8 inches in diameter. This is adequate for combat, but notably worse than his typical performance with standard M1911s, where he routinely achieves 4 to 5 inch groups at this range. He continues firing, emptying the drum. Rounds 21 to 35 feed reliably. Round 36 shows a brief hesitation. The slide strips the cartridge but doesn't fully chamber it. Hayes performs a tap-rack drill, tapping the magazine to ensure seating, racking the slide to clear the stoppage, and continues. Rounds 37 to 40 feed without issue. 40 shots fired in approximately 2 minutes. The barrel is hot enough that heat radiates through the slide. His hands ache from controlling the awkward weapon. But the drum worked. It fed 40 rounds with only one minor stoppage, and the pistol functioned mechanically throughout. Hayes conducts a second evolution, testing rapid fire rather than deliberate aimed shots. He loads a fresh drum and fires as quickly as he can acquire targets and press the trigger, approximately 2 rounds per second, the practical limit for aimed fire from a semi-automatic pistol. This reveals more problems. The rapid firing creates heat that builds faster than the pistol can dissipate. By round 25, the slide is too hot to touch. By round 32, he smells burning lubricant as the action heat breaks down the oil on the slide rails. By round 38, the action becomes noticeably stiffer, the thermal expansion of metal parts creating tighter tolerances that increase friction. The final 2 rounds feed, but with visible resistance. Hayes completes the string and immediately inspects the weapon. The slide shows discoloration from heat. The barrel is too hot to handle. This is far more thermal stress than the M1911 experiences with standard 7-round magazines, where shooters typically fire a magazine, reload, assess, and fire again, allowing heat dissipation between strings of fire. The drum's 40-round capacity encourages firing all 40 rounds in rapid succession, creating sustained fire the pistol wasn't designed to endure. This suggests tactical limitations. The drum provides capacity for sustained fire, but the weapon cannot mechanically sustain such fire without heat-related problems. Hayes conducts additional testing over the following 3 days, firing approximately 600 rounds total through 3 drum-fed M1911s. The testing protocol examines reliability across ammunition lots, testing different manufacturers' .45 ACP ammunition to ensure the drums work with normal ammunition variations. Results show the drums are sensitive to cartridge dimensions. Ammunition from one manufacturer with slightly oversized case heads causes binding in the spiral track, creating failures to feed. Environmental conditions. Testing with cold, heat, and moisture exposure. Cold temperatures stiffen the drum's mainspring, reducing feed reliability. Moisture creates corrosion in the spring mechanism that binds the spiral rotation. Neither condition affects standard magazines significantly, but both substantially degrade drum performance. Durability testing, firing sustained strings to evaluate component longevity. The magazine catch shows wear after approximately 400 rounds, requiring replacement. The drum spring loses tension after approximately 600 rounds of repeated loading and firing, requiring spring replacement. The drum body develops small cracks at stress points after approximately 800 rounds. Tactical handling, testing magazine changes, manipulation while wearing gloves, operation in darkness. All tasks prove more difficult with drums than standard magazines. The weight and bulk create handling problems that training can mitigate but not eliminate. firing from various positions and ranges, comparing accuracy with drum versus standard magazine. The drum consistently produces larger groups, approximately 30 to 40% increase in group size across all conditions tested. This reflects the weight distribution's negative effect on natural pointing and holding stability. The formal evaluation report, filed February 15, 1918, concluded, "The 40-round drum magazine for the M1911 pistol demonstrates mechanical feasibility, but introduces numerous practical limitations that question its tactical utility." Positive findings: the drum mechanism reliably feeds .45 ACP ammunition with approximately 6 to 8% stoppage rate, acceptable for combat use. Capacity of 40 rounds provides sustained firepower exceeding standard 7-round magazine by factor of 5.7. Mechanical reliability is adequate for combat employment given proper maintenance and quality ammunition. Negative findings: weight of 3.8 pounds loaded creates severe handling difficulties. Accuracy degrades approximately 30 to 40% compared to standard magazine due to altered balance and holding fatigue. Heat accumulation from sustained rapid fire causes reliability degradation and potential damage to weapon. Drum durability is questionable, with component failures observed after 400 to 800 rounds. Incompatibility with standard holsters and carrying equipment limits practical deployment. Tactical assessment: the drum-fed M1911 occupies an awkward middle ground between pistol and submachine gun. It provides more sustained fire than standard pistols, but less than purpose-designed automatic weapons. It retains some pistol characteristics, compact size, semi-automatic operation, but loses others, one-handed usability, quick deployment, and comfortable carry. For scenarios requiring sustained close-range firepower, dedicated submachine guns, Thompson, when available, provide superior capability. For scenarios requiring pistol characteristics, concealment, backup weapon, officer sidearm, standard M1911 with multiple standard magazines provides better handling with adequate capacity for extended engagements. The drum magazine represents sound engineering applied to a poorly defined tactical requirement. The problem, insufficient pistol ammunition capacity, is better addressed through alternate means than transforming pistols into weapons they were not designed to be. This recommendation was accepted by the Small Arms Division in March 1918. The drum magazine program was terminated, the 3 prototypes retained for reference, and the technical drawings filed for future consideration if circumstances changed. The drums never saw combat use. American forces deploying to France were equipped with standard M1911s carrying 7-round magazines, typically issued 2 to 3 magazines per pistol. Officers leading assaults carried pistols for self-defense, but relied on rifles, trench shotguns, and grenades for offensive firepower. The Thompson submachine gun, when it finally entered production in 1919, filled the role that the drum-fed pistol had been intended to address: sustained close-range firepower in a portable package. The Thompson's shoulder stock, longer barrel, and purpose-designed automatic action made it far more suitable for sustained fire than any pistol modification could achieve.